Sankalp Paranjpe. He is an AWS Cloud Captain boosting 2 times AWS certifications, including AWS Certified Solutions Architect, Associate and AWS Certified Cloud Practitioner. Additionally, he has been contributing to communities by giving technical talks for community growth and development. Get ready for an eye-opening session on Introduction to AWS Serverless Exploitation.
Give him a big round of applause.
So hi everyone, how are you all? Are you guys excited to dive into serverless security? So let's get started. So let me introduce myself. So I am a SRE intern at Intangles Labs in Pune. Also, I am a final year student graduating next month. Apart from that, I was selected as one of the AWS Cloud Club captains, where AWS selected 10 students from India and 50 students around the globe back in 2023. And at that time, I was selected. Also, I am a cloud security and DevSecOps enthusiast and learning and exploring this field. So let's get started with our topic. So agenda of this particular session. So first we will be briefly introducing AWS serverless services, the services which are provided by AWS where we can deploy our applications. Then we will see basically the shared responsibility model for the security. So how security is implemented, what are the responsibility of the cloud provider, as well as what are the security related responsibility of the customer. So this is something related to shared responsibility model. After that, serverless services, and after that, we will be seeing the top 10 vulnerabilities related to serverless applications. And one demo we will see and see how we will be exploiting that particular injection vulnerability. So let's get started. So what is serverless? What is serverless? Why serverless? So is it no servers? So actually, it is servers are there, but we are not managing. A cloud provider is managing servers for us, and we are working on our application codes. So it helps us to stay focused on building our application, building our business, rather than managing the infrastructure and patching or related to infrastructure management. So this is how serverless helps us to scale our business and focus more towards our product rather than infrastructure. So here comes, first we will see shared responsibility model where AWS help the customers to implement the security, and later we will see for the serverless. So AWS provides us with different services, the compute, storage, database, and networking. These are basic services, as well as we have some of our data, customer data. Also, AWS provides us with the security services like encryption or after that firewall network, but it is our responsibility. So there comes two things: security in the cloud, security of the cloud. So security in the cloud, that is our responsibility, where we are having our data, we have to configure that, and providing that particular service or compute or like these basic services, that is AWS part. Now, what is different in serverless? How it is different in serverless? So when we execute Lambda functions, there is a service called AWS Lambda, which we execute. So in that, the customer writes the functions, codes, and libraries. Those are the customer's responsibility, how he is going to write. And underlying infrastructure or the compute services, execution environment, runtime environment, those things are managed by AWS. So we are independent, we can manage our product and focus building our product. Now, coming to serverless, first benefit was that we are able to take our idea to market very fast with serverless, as well as we need not to worry about patching vulnerabilities of the server management, critical those stuffs. Then lower the cost, then adapt at scale. We can scale our applications. So since we are not managing, AWS is directly managing. So we can directly scale our applications. Now, few AWS services include AWS Lambda, which we will be seeing in this talks to how to exploit Lambda functions to gain the access. Then there is something called API Gateway, DynamoDB, and there are a list of services which we can check on AWS website. Now, how actually these services work. So for a brief introduction, let us go through the 3 services. Those are AWS Lambda, API Gateway, and Amazon Cognito. So we'll go through very basic introduction of these particular services, and later we'll dive into the security vulnerabilities. So AWS Lambda basically provides us to run our code without provisioning of an infrastructure. We need not to worry about the infrastructure. Also, we can write those particular Lambda functions in our languages, like using Node.js, Java, or Python, and other languages. Apart from that, AWS Lambda functions are deployed as a container. So so those are encrypted with one of the service called key management service. So hence your container and Lambda function is secure. Okay. Also, there are different policies and different privileges that we can create, which will help us to secure the Lambda functions. So this is from the defensive side. Later, let us dive into the offensive side of it. So API Gateway, so it is fully managed service for creating, updating, publishing, maintaining the secure APIs. So for API management, we use particular this service. Then Amazon Cognito. So this particular service is used for authorization and authentication. So it provides customer identity and access management for using that particular authentication or authorization service in your product. Now, there are some event sources. So how this Lambda function will get triggered, how this particular Lambda function will execute, how this particular action will happen. So there are some different event sources. One is the cloud storage events. So that is S3 data events, or there are events for Azure and Google Cloud as well. Also NoSQL database events. So there are different sources, HTTP API calls, or there are messaging queues involved. So these events execute the Lambda functions. And where we execute a Lambda function, there something unusual happens and there is a vulnerability. Now we will see top 10 serverless risks. So first is injection, broken authentication, broken access control, insecure serverless deployment, sensitive data disclosure, then security misconfiguration, insecure third-party dependencies, insecure application secret storage, inadequate monitoring and inadequate function monitoring and login, and DOS. So let us dive deep into each of the vulnerabilities. Now, this is one of the use case which we can exploit for resume analytics. Basically, this particular Lambda function is there, which is used for capturing your resume and then generating its basically extracting a text and then generating for resume analytics. Now here, there is no input validation, and because of that, attacker will be able to upload any file, and again, it will be able to get the shell. Now, how to mitigate? So we shouldn't trust any input. We should always have input validation. Always, we should provide least privileges. So there is a principle of least privileges where we should give least privileges required for that particular task to that particular role. Apart from that, if we have threat modeling, then we should consider all entry points, all events, from where the event will trigger, for what particular purpose this Lambda function is written. So we should analyze everything at the threat modeling stage. Now, broken authentication. So Amazon Cognito is basically used to implement authentication and authorization. So when client tries to authenticate, basically a token gets verified through Amazon Cognito and authentication occurs. So here there is some misconfiguration occurs if it is not properly used by developer, or if developer creates his own authentication. So that is not recommended actually. So building own authentication schemes is not recommended. We can directly use single sign-on or Cognito. So those particular things are recommended to mitigate the service. After that, we should not interact. We should basically use secure API keys and certificates to authenticate and mitigate this issue. Now, broken access control. So what happens is that if we do not follow least privilege, the access control, there's an issue with the access control. Because if you are giving access to all the S3 buckets, then it is wrong. Because the user or the person has to access some specific things, and it should be like, we should give them specific access. Else, you might not know what will be wrong further, and this giving access to all the resources is wrong practice. So we can mitigate it. We can give a specific action that the user can put the object in the S3 bucket, and the bucket, specific bucket also we are mentioning in the policy. So this is one of the best practices to use the least privilege principle. Okay. So one is the sensitive data exposure. So in this, you have, while implementing that particular Lambda function or any function, you have accidentally stored the credentials there. So instead, we should use secret manager or key manager, which we can use to rotate at the later stage. So we shouldn't hard code our credentials. Now, security misconfigurations. So in this, basically, if you have not granted the least privilege, we are able to access the bucket, we are able to copy the bucket because there is no permission attached. It's one of the misconfigurations. So we are able to use the random attacker profile, and then we are able to copy all our bucket data of the S3 bucket. Now, there are possibilities that our application would be using any third-party dependencies. So those third-party dependencies should be used from a verified source. Basically, if they are consumed from any third-party source, so we should be aware that it should be secure. So we should perform the SCA, the source software composition analysis, SAS, to basically prevent these types of further issues. Now mitigation, so first we should maintain inventory list of software packages and dependencies. Also, we should scan our vulnerability dependencies. So in each phase of software development lifecycle, we can integrate security, that is DevSecOps. Also, apart from that, we can remove the unnecessary dependencies which are not required, which are not required by the serverless functions or those Lambda functions. After that, we should upgrade all the packages or stay with the latest versions and apply all the relevant software patches. Now, insecure storage of secrets. So there are so many Lambda functions which we use during a deployment of applications in the serverless stack. So these many Lambda functions would be using many secrets. So how to manage them? So we instead use a manager, and using that we can directly rotate the secret after specific duration. Hence, there will be no hard-coded secrets, no pushing to any repositories, and nothing like that. So hence, it will be stored securely. So this is one of the mitigation from AWS. So this Lambda function can request the secrets to the secrets manager. Then secrets manager will basically decrypt the secret and transmit the secret. So here a service called key management service is involved. So for the key for encryption and decryption purpose. Now DOS. So there are different Lambda functions which has time limit of 15 minutes. Okay, so those are running in parallel. Now bots are there. So those are trying to put many requests upon the API gateway because your request is going through API gateway. Now again, malicious request will be taking all the sources, all the Lambda functions. So it will result in resource exhaustion. So to prevent it, basically, it was one of the multi-part parser vulnerable redos. So this function is vulnerable to DOS attack. So let's get with the demo, or I have recorded a video for you. So let's get started with the video. Okay. So I have recorded a demo and I have deployed a vulnerable application using CloudFormation. So CloudFormation is one of the infrastructure as a code provided by AWS. So here you can see I have deployed a particular vulnerable application. So this particular application takes a file, we upload a file, and this will convert that particular file into HTML, means Word document will be converted to HTML. So here is a document file which I have taken, and the URL is there, so we have uploaded it. So we will press the submit button. So it's one of the input box. So we will press the submit button. Before that, we will use the Bob suit and make the intercept on, and we will intercept the particular request. We are able to see that we have intercepted the particular request, and we will send it to repeater. Now, basically, we are able to see that the particular endpoint, there are different headers. X Amazon request ID, API gateway, these headers are there. So we are able to identify that this particular application, from attacker's point of view, we do not know that at the backend we are using AWS. Right now the endpoint basically is of the Amazon AWS, but it will be, in real case, it will be behind the DNS. So attacker will basically get to know through these headers that this particular application is behind AWS serverless services. Now we are able to see the text was converted to HTML, Word document was converted to HTML. Now we will try to execute command. We will try to execute a command and check if we are able to exploit any injection vulnerability. And we will intercept that particular request. Okay, so we are able to echo that particular hi. So again, we will try what other commands we are able to use, and if it gets executed. Okay. So again, we will be able to get that. We are able to execute the commands, and hence there is a command injection here. After that, later we will be seeing how we will exploit the keys. So again, we are able to get the ID. Now we will try to cat this etc password file and check check for these particular files. So we are able to get the contents of the etc password file as well. Now after that, we will check if we are able to get any environment variables as well. So if we are able to get the environment variables, we will get the access keys, and we will log in to that particular through console. We will log in through CLI to that particular AWS. So yes, we are able to see that we are getting the session token. We are getting basically the access keys, access key ID, and everything we are able to get. So this is one of the misconfiguration, and now using these particular keys, we can log into that particular account, and again we can, we or attacker can basically launch the different P4 instances. Those cost very high, and this will result in high billing for the organization. So this was a small demo which I recorded. So moving further, so some of the best practices. So we should follow the principle of least privilege, and we can use IAM Access Manager to verify that. There is a feature of IAM Access Manager which will basically help us to verify all the permissions and all the accesses. After that, we should use Secrets Manager. We shouldn't store any credentials in the Lambda functions or any of the codes. After that, we should use SCA tools to scan the dependencies Also, if we are using API gateway, we should use DAST tools to scan. After that, we should have a basic incident response process. Apart from that, there are some security frameworks specifically for serverless stack. So first is OWASP Top 10 serverless, then AWS Startup Security Baseline, CIS Foundational Benchmark, and AWS Well-Architected Framework. So we should implement the controls specified in these particular frameworks. Apart from that, we should continuously monitor our environment. There are services like CloudWatch, CloudTrail, Amazon Detective is there. So if any incident occur, Detective will help us to detect if any incident is there. So what is the root cause of it? So it will help us to detect incident. Now references. So here we come towards the end of our talk. So let us connect over social media. So LinkedIn, Twitter, and my website. So towards the end of the talk. Thank you, everyone.